everyone, we're going to solve each trig equation and give it, three things. We're going to solve the equation, give a general formula, which we've kind of already done that in some other videos, and then list 6 solutions. So that has to do with the trig functions are periodic. So the first thing we're going to do is solve, and these are pretty basic. So we know that theta, if it's just this, equals pi over 6, and theta equals 5 pi over 6. That's where sine of theta is 1/2. Now to give a general formula, since the period of sine is 2 pi, you just write 2k pi to both of these. So there's your general formula. And this is where k belongs to the integers. It's the integer. And now we have to give 6 solutions. Well, we know when k is 0, that means we're not dealing with those two. That zeroes that out. We just have pi over 6. I don't think I left a room. Let me scoot it over. That means we would just have pi over 6 and 5 pi over 6. Alright, now we have to do 4 more. So we're going to let k equal 1, and we're just going to substitute 1 for that. So we're going to get pi over 6. So let's do it this way. Alright, so pi over 6 plus 2 pi. And 2 pi would be 12 pi over 6. And then we can also do 5 pi over 6 plus 12 pi over 6. Because that's 2 pi. And then, so when you add those up, that's going to be 13 pi over 6 and 17 pi over 6. I still didn't leave enough room, did I? Let me do this. Do it like that. Okay, so we need 2 more. So I'm going to let k equal 2, and that means 2 pi, which would be 24 pi over 6. Whoops. And 5 pi over 6 plus 24 pi over 6. And then just adding those up, you're going to get also 25 pi over 6 and 29 pi over 6. And I'm just doing positive. You also could do, so that's my solution set here. You could also do k as -1 if you need to get -1s, and just subtract these out. I like doing -1s. We'll do the -1s next. Alright, so the next one we have tan of theta is 1. So there's actually 2 solutions here, which is pi over 4 and 5 pi over 4. I'm not going to use this one. I'm just going to go at, well, we can use that, but we're just going to use this one because the period of pi is, the period of tan is pi. So if I write the general formula, I'm just going to write okay, excuse me. I do have a cold, so I'm kind of sniffling today. So basically, the general formula would be theta equals pi over 4 plus k pi, because remember the period for tan is only pi. And then the 6 solutions, if we let k equal 0, we just get pi over 4. Alright, if we let, so let's do it that way. So that would be pi over 4 plus 0 times pi. If we let k equal 1, we get pi over 4. And I'm going to go ahead and just write 4 pi over 4, because 1 times pi is just pi. So that gives you 5 pi over 4. That's why we didn't have to really set this one up, because this one's directly, it's pi radians difference there. And then what I'm going to do is go ahead and let k equal -1. The reason I like to use -1 is because you already have the plus here. So that's just going to be pi over 4 minus 4 pi over 4. And that's going to give you -3 pi over 4. Now, we need 2 more. So we're going to do k equals 2, which would be pi over 4 plus 2 pi, which is 8 pi over 4. So that's going to give you 9 pi over 4. And I'm going to go ahead and do k equals -2, because then I just have to subtract. So I get -7 pi over 4. And I still only have 5, so let's do k equals 3. And you get pi over 4 plus 12 pi over 4, which should give you 13 pi over 4. I didn't write this down very well, but anyway, there's your 6 solutions right there. Okay, next. Tan of theta equals -√3 over 2. So we know that theta equals theta is 5 pi over 6. The general formula is going to be k pi, where k is in the integer. All right. And then we're just going to, we know when k is 0, we get 5 pi over 6. And then we're going to keep doing like we did before. So let's look, k equals 1. If k is 1, that's just 5 pi over 6 plus pi, which is 6 pi over 6. And that gives us 11 pi over 6. And let's go ahead and do k equals -1, 5 pi over 6 minus 6 pi over 6. So that gives us negative pi over 6. And then let's try k equals 2. That's going to be 12 pi over 6. So that gives us 17 pi over 6. And let's go ahead and do k equals -2. So that's 5 pi over 6 minus 12 pi over 6. And that gives us -7 pi over 6. And we can do another one, k equals 3. So that would be 5 pi over 6 plus 3 pi, which would be 18 pi over 6. And that would give us 23 pi over 6. That's just one way to do it. You could use all positives if you want. So that's your general solutions. All right, the next one is cosine of theta is -√3 over 2. So I have theta equals 5 pi over 6 plus 2k pi, or theta equals 7 pi over 6 plus 2k pi. All right, so when k is 0, we get 5 pi over 6 plus 0 pi, and we have 7 pi over 6 plus 0 pi. And that's just going to give us, let me move this out. That's just going to give us our 5 pi over 6 and 7 pi over 6, our original ones. Now we need 4 more. So the only one I'm going to use is 1 and -1. So k equals 1. That's going to be 5 pi over 6 plus 12 pi over 6, because that would be 2 pi, and 7 pi over 6 plus 12 pi over 6. And that's going to give you 17 pi over 6. and 19 pi over 6. And for the other two, I'm just going to do minus 1. So that's 5 pi over 6 minus 12 pi over 6. And 7 pi over 6 minus 12 pi over 6. And that gives us negative 7 pi over 6 and negative 5 pi over 6. Yeah, negative 5 pi over 6. And those would be your 6 solutions. All right, we have cosine of theta equals 0. So we know there's only one place that happens, and that's pi over 2 plus 2k pi. It's your general formula. So we know when k is 0, we get pi over 2. When k is 1, you're going to get pi over 2 plus 2k pi, or 2 pi, which is 4 pi over 2. So that'd be, let's see, pi over 2. We also know it's 3 pi, just a minute. Okay, so if we just do the pi over 2, we also know it's 3 pi over 2. I left that one out. So I'll write it here. So theta equals 3 pi over 2 plus 2k pi. So when we get this one, this will be 4 pi over 2, which is going to be 5 pi over 2. And when this one's going to be 3 pi over 2 plus 4 pi over 2, and that's 7 pi over 2. On this one, what I suggest doing is notice that there's a pattern. There's a pattern on all these, and you can kind of guess, but it's my numerator's going by 2 pi. So the next one's going to be 9 pi over 2, the next one's going to be 11 pi over 2, and just go like that, because you know it changes every pi. All right, and the last one, we have sine of theta equals square root of 2 over 2. We know that that is going to be pi over 4 plus 2k pi. And sine's positive and also quadrant 2. So that's 3 pi over 2 plus 2k pi. All right, so we need, there's your general formula. We did that. We'll get this 6 solutions. We already know that we have pi over 4 and 3 pi over 4. We also know that 5 pi over 4 and 7 pi over 4 don't work, because that would be negative square root of 2 over 2. So I'm going to let k equal 1. When k equals 1, you get pi over 4 plus 8 pi over 4. And we also have 3 pi over 4 plus 8 pi over 4. So that gives us 9 pi over 4 and 11 pi over 4. And what I would do for the next one is just let k equal negative 1, because you already have the work already written out here. So negative 1, so that would be pi over 4 minus 8 pi over 4, and 3 pi over 4 minus 8 pi over 4. And those two solutions would be negative 7 pi over 4 and negative 5 pi over 4. And that's it. So that's your 6 solutions. The next set we're going to do is the same thing, but it's with the arguments that are other than theta. So you have more complicated arguments. Thank you and have a nice day. Bye-bye.